Good morning, Edwin. Going forward. Be here on time.
Yeah, I'm sorry.
It's all right. Just in general with everybody. Let's see. 1, 2, 3, 4, 5. All right. Okay. So I see 1, 2, 3. So there's only about half of us here. This is at the moment what I'd like for us to do. However, I think this is going to be, I think we're going to take this a real, lazy pace. I apologize. It's not like, so I think what's going to happen, normally I think we can knock this out in one shot, like one day, but this might be where we may just do half, or, I mean, I am going to record the lesson, of course, for everybody else who's not here. So, all right, first things first, as I finalize attendance, just look at the top 4 problems, and then we'll talk about these announcements momentarily. So the top 4 is just basically, oh, give me calculators. You're just basically going to divide the two numbers. And then that's basically your unit rate. That one right behind you. And then Jason. And then pass it over to Catherine, please, sir. So really quick, the first 4 problems is for, what you do is just divide the numbers and see what you get. That's all you're going to do, and that's going to be an intro to what we're going to talk about regarding ratios and proportions. So just look at the first 4 problems. I'll give you a minute or so. Okay. Maybe 2 to 3 minutes.
For the first one, will we put miles per hour?
Yeah, you can do that.
What do you want us to do?
On the first 4, the very top, it says view unit rates. Basically, you're just going to divide the 2 numbers.
Okay.
That's what you're doing.
So, I just do 200 divided by 4.
Yep.
For this one, this is $10. I would put the without rate.
You don't need to. It's one of those you can, but you don't need to situations. Yeah, but that you have to. Yeah.
Okay. And do I put the money sign?
You can. Yeah, I would. That's a good question, Andy. Yeah, I would. be right with you.
You told me. Huh? There. Tell me how, tell me how, tell me how.
Huh?
Tell me how.
All right.
One day at a time.
One day.
All right, sorry about that. All right, here's what we have going on.
It seems easy.
Yeah, it's not that bad once you get going with it. I don't know what's going on. I don't know what's going on with the screen today. All right, so the first two, yeah, it's not that bad. Because with the unit rate, you're just dividing the two numbers. So for instance, 200 miles in 4 hours. What would be the unit rate? Yeah, you
50
just
miles in
divide.
1 hour.
50 miles per hour or 50 miles for 1 hour? That's all that's going on right now. Or, I know it's more popularly known as 50 mph, which that would be an acceptable answer. So I know some of you really like that. That's fine. Okay, what about the second one? You paid $10 to buy 8 pounds of sugar.
125 per pound. 125.
125 or $1.25. And a lot of times you see in the store /LB per pound. See that often in the supermarket, right?
Yeah.
Like at the deli counter or the produce stand, they say tomatoes, I don't know, 159 per pound. What? Okay, what about how much did Julia pay per gallon for gas? So she paid 12. How much?
2.5.
So for 12.50.
250 a gallon.
12.50 for 5 gallons.
I got 2.5.
Yeah.
Okay, so here's what would have happened. On your calculators, it would have said 2.5, but with
Put
money,
a zero, right?
yeah, with money, you have to put that additional zero. And then often at gas stations, you see 250/gallon. If you think about it, we're gonna be seeing all this. Whenever you go shopping, your family, supermarket, or a lot of you are starting to drive soon. Miles per hour, amount of money per gallon of gas. If you're driving, you gotta pay for that gas tank, right? You're seeing all this going forward. And then this last one. So Willie scored 100. Completed a 25-question test. How many points was each question?
4
Yep.
points.
That's right. 100 divided by 25. 4 points. And then an idea might be the label, which some of them, I mean, they were labeled here. But especially labeling down the road. I know when we deal with ratios, proportions, we're going to be dealing with a lot of labeling. Like with sides and everything. Because when we start dealing with, especially with ratios and proportions, because what's going to happen, I'll tell you in a moment. Labeling is going to be the key, because that's going to help us determine how we set up these problems. All right.
Are there any people on the Zoom?
Right now, no one in the Zoom. I'm surprised. I know a couple people are out because of testing, and then other people, who knows. But I'm also recording through the smart board. So remember,
You could just put it in.
yeah, it's gonna be in. Yeah, this recording is gonna be in school regardless when we take a form. All right. So let's talk about ratios and proportions. And actually, you might have seen some of this before. Ratio and proportion is sort of similar to reducing a fraction to the lowest common denominator. Now, here's the one difference though. Ratio, you say A to B. You can see that this is a fraction form. This is colon form. Word form, or written. So there's going to be ways you're going to see how ratios are written. And this is a fraction form. But this fraction form, you can see it in colon form. Now I'm going to put two-way arrow. Because the colon form, you can write it as fraction. But remember, the first number is always the top. So you could say 5 to 10 as well. No. No, you don't have to per se. No, not necessarily. But I'm glad, the one reason why I'm glad you mentioned it, because that's how a ratio can be seen in any of these three forms. So, no, that's good. I'm glad you wrote it, mentioned it, because I want everybody, this is the key, I want everybody to see how all three forms are all related to each other. That's if you have two numbers. Now, sometimes you might have three. And there's going to be some problems where you're going to be comparing maybe three, because like with triangles and stuff, an idea might be, let's say you have a triangle, but then you shrink it, but it has to be proportional. Like either you shrink it, or if you enlarge it, Same thing, the proportions have to match. And then similarly, if you have three, if it's three or more, it's gonna be more in this form, colon, or written, like if you're gonna compare three values. Because fraction, it gets a little tough because if you put like A over B over C, then that gets a little weird. But if there's like three, then you can write them these two ways. But with the three numbers, it's always gonna be either they get simplified, you divide them all by the same number, or you multiply them all by the same number. So that's what's going on with if we have to compare three values. All right, now let's talk about. So basically, with a ratio, it's similar to the fraction. You want to simplify it to the lowest terms. Now, if we look at both problem 1, all right, and problem 1A and B, I should say. Now, both A and B, you can write them anyway. Yup. So all three all right. They all mean the same thing in the end. I want everybody to see that. That's connection number 1. Now here's the second part. So get ready. Now if you look first at just 1A, and actually 1B is going to also work. But let's focus on 1A for a quick second. What number can we divide both 5 and 10 by?
2. I mean, no, not 2.
Go the opposite way.
1.
Or you can divide by 1. 5. In the end, it's going to be 5 because both 5 and 10 are divisible by 5. Now, I know where you got the 1 and the 2 from because what happened was divide by 5. You can do the same thing here. 5 to 5, 10 over 5. In the end, well, if we simplify 5 over 10, if we divide both the top and the bottom by 5, what will we get? We divide both the top and the bottom by 5. Or
if you do 5 divided by 5, that's 1.
yup,
And then if you do 10 divided by 5, that's 2.
yup. Okay, so 5 over 10 simplifies down to 1/2. Now, if you did it ratio form, you get the same result because 5 colon 10 becomes 1 colon 2. And if we wrote in words, 5 to 10 simplifies to 1 to 2. That's really what's happening in the end. And then a similar situation could take place. You can divide by 5 as well. Both of these problems. Divide by 5, divide by 5.
Only 5 divided by 5 is 5. 5 divided by 5 is 6.
It'll be 5 over 6. And your answer. 5 to 6, 5 colon 6. All right. So basically with ratios, it's sort of like dealing with fractions. You just simplify. Now, and again, if you see it in any of these forms, you can write it as fraction form, or you could write it as any of these other forms. They all mean the same thing in the end. That's why, like up here, same thing. And we're gonna be going with like some of these, we're gonna maybe rewrite it in fraction form, so it might be easier for everybody to simplify. And then if we need to, we can go back to like the colon form or the written form. Now, again, anytime we're dealing with 3 numbers, you're better off writing it in one of these 2 forms. So that's if you're dealing with 3 numbers. Because if you deal with fraction, then it gets difficult. All right, and then there's also going to be other connections. Let's say if you deal with 3, like if you deal with 2 or 3 sides from one diagram, 2 to 3 sides of another diagram. All right, here we go. Now, the next 2, let me make these a little bigger. Make that even bigger. All right. Sometimes we're gonna play a game with you where you're gonna need to convert some values first before you can compare. You'll need to convert some values. So some of these problems we're going to have to convert. So you might be given a scale, yet you may not always be given the scale to some of these types of problems. So, question I have for everybody. I know we have I know we have 3 inches over 2 feet. Now, can we exactly, I know we have inches and feet. Now, do they necessarily measure the same thing? Like, no. However, what do we know about feet in relationship to inches?
12 inches equals a foot.
Equals 1 foot is 12 inches. So, is there a way where we can rewrite this ratio where the units are the same?
Yeah, I know 2 feet is 24 inches.
Okay, that's a good start. Andy said 2 feet, 24 inches. All right, so now ask yourself, if I have 3, can we simplify 3 over 24?
Yeah.
Yeah, what can we divide both 3 and 24 by?
Two.
No, you take a lot of 2.
Maybe. Not by 2 or 1.
3.
3. Divide them both by 3.
24 divided by 3 is 8.
Now, is the 8 gonna go on the top or the bottom? Yes.
So it'll be 1, 3.
Yep. You know, I mean, you can write inches. Now, I know this would be specified down the road, but the fact that you said the 8 goes on the bottom is key. Because in the past, I've seen people write the 8 on the top, or they just write 8. They don't realize there's a numerator of 1. That one that's why I'm gonna start this type of problem, because chances are, maybe on a quiz or a test, if you simplify to the lowest terms, you need to realize that 1 exists. It's not go goodbye. All right, now, look at the next one, you have a similar situation. I have 24 ounces over 2 pounds. So if ounces over pounds,
It'll be 32,
32 ounces.
where's the 32 ounces going?
Bottom,
In the place of 2 pounds, yeah.
and I think you can.
Yeah, you that was,
2, right?
2 is a good start. I mean, if we divide both by 2,
You get 12 on the top,
okay.
and then for the bottom, you get 16.
And could we go any further with the 12 and the 16?
You can?
Oh, yeah, you can.
You can divide. You can divide by 2 then?
You can divide by 2. Are there any possible bigger numbers than 2?
Huh?
You go by 4. Now, if you went by 2, that wouldn't be bad. So if you went by 2,
You get 6.
you get 6 over,
6 over 8.
yup. But then you can simplify 6 over 8 again. That would become,
So would that be the right way?
well, the goal is you want the biggest possible number. You want to try to divide both numbers by the largest possible number. So in this case, actually, now what you could, so pieces, going piecewise is not bad. Don't get me wrong, I'm never going to say this method is not wrong. I mean,
So it just takes longer?
it will take longer. However, if it works for you, I don't have a problem with it. If it works for you, I'd rather you take that extra minute to make sure you understand 100%, get that problem right, versus you skip, and let's say you divide that accidentally by the wrong number, and you got different numbers here, that's worse. Or, because I know I'm going to be a broken record. I'd rather you be the last one finished with a test assignment, but there's been a difference between a pass and a failing grade. Was it worth that extra few minutes? Because if you don't pass, chances are you're going to have to either do some corrections or add-on activities, and then you're just wasting, and you're losing more time, and then you're going to recoup that time learning what the new stuff that's taking place. Okay, questions on this problem here? Now, order is going to be important. And I'm going to tell you why, especially starting with the next problem, because the units in a lot of these problems are going to be the same. But the units are going to be written, they're going to mean 2 different things at times. And I'm going to show you what this next problem has to do. I don't know why the screen's acting funny. All right, let me. Okay,
Yeah, I think this part got chopped a little.
yeah, this rectangle, back. I'm gonna rewrite it over here so that we can see it on one screen a little bit better. It's gonna be the same rectangle. So for number 2, here's your actual new rectangle. I'll put it in there.
Oh.
So what's gonna happen is, they're gonna say the width, here's your width, here's your length. But notice the order. Here's where we really have to start being careful with order. So I need everybody's attention. I need it up here, like right now. Okay. Really pay attention with this next problem. All right, Catherine, Zoe, Kevin, everybody, are we ready? I need everybody's attention here. Okay. Key is right here. The width to length. Say it again. 32. So you can do the width, 32 centimeters, colon, length, 60 centimeters. You can do it that way. I'm all right with that. Okay, let me give you all more space. So you said the width. Here's your width. Length. What's that? In this one, not yet. Well, it's just understood because here's what's gonna happen. When you write it this way, you can eventually write it as a fraction. So this is your width, that's your length. So now it's just a matter of simplifying the ratio or simplifying your fraction.
So you rather do the fraction?
It's up to you. With two numbers, the only reason why I show fraction is because when it comes to simplifying fractions, we see simplifying a fraction. But if you simplify the ratio, if there's only two numbers, it's similar to simplifying a fraction. So I'll accept either way. The key is the next step when you do your simplification. And when you do your simplification, so we have to first figure out what number can we divide both 32 and 60 by to get whole number results. So you have to ask yourself, what number can we divide both 32 and 60 by in order to get a whole number result? So that's something to think about. How much? Okay, we can start with 2. So if we divide 32 by 2, what do we get? What's 32 divided by 2?
16.
Uh-huh. And then what's 60 divided by 2?
30.
So we can say width 16 centimeters, length 30 centimeters. Can we possibly simplify this fraction further?
Yeah.
What can we divide both 16 and 30 by?
2.
Do it again.
It would be 8.
8 and what?
8 and 15.
8 and 15, that's right. So divide both of them by 2. 16 over 30. Becomes 8 centimeters. Now, is the 8 the width or the length? What was the top number?
That's
The width, okay. And what about the 15? Width or length?
9.
Length.
So 2. Oh, 8 is 30.
8 over 15. Because at this point, we can't go any further, right? Because the only numbers that would work were 3 and 5, but 3 and 5 is not going to work for the 8, so you stop here. But the other thing, too, whenever we're dealing with same units, which may not always be the case, but if we are dealing with same units, we have to include what else? What's the other specifier, the quantifier? What does the 8 centimeters mean? Is it the length or the width? But I'm just saying in general. So it's just a general, like 8 centimeters, okay, that's our width. Because if we just write 8 centimeters,
So for this equation, tell me about the length and the width.
right,
So don't forget the length.
right. Don't forget, what does each measurement represent?
Okay.
That's the important part. Because earlier we were talking about ounces, but I know like here and also with the 1 over 8 inches, 1 inch to 8 inch, we didn't necessarily specify what did each represent. For all we know, that could be length, width, or with the ounces, could it be ounces of cereal versus ounces of milk? I'm just throwing just a general example. But like this problem, we specified, okay, if you have a rectangle that's 32 inches wide and 60 inches long, it's going to be proportional to another rectangle that's 8 inches wide and 15 inches long. That's what we're trying to get here. Our ultimate goal is trying to figure out, when we simplify, what's the common like ratio oh, right, 15 centimeters here, but we're trying to figure out what's the common factor for your dimensions. What's the common factor? Like, what's the common number we use to multiply both dimensions or divide both dimensions to get the new size? I'm trying to think of an example. All right, well, think about back in the day. Anybody used to play Mario or Super Mario? Any of those? Okay, when you played the Super Mario game, Mario ate the mushroom, got bigger, right? But it was a proportion. He eventually went from, I don't know, maybe if he was, 1 inch. Like, he went up to maybe 5, but everything else had a match by, let's say if his leg was maybe 1/4 inch, I multiplied by 5. Arm, 1/2 inch, multiplied by 5. So everything was proportional, like he grew proportion-wise.
Same length.
When you get that much.
I mean, very different length. Times more.
Right. So basically, every part was multiplied by the same number. Yup. And then until he got hit by like an enemy, like the mushroom or turtle or what have you. Yup. Then he would shrink, but his whole body shrunk proportionally as well. So that's basically what we have going on here. We're looking at proportions. Like, how, proportion-wise, how much did they get bigger? Or proportion-wise, how much did they get smaller? So that's what we have going on today. And then that's what we're going to be doing going forward. All right, so all right, questions before we go to the next activity. So what we're going to do now with the next activity, now there's going to be a couple problems that, well, the next one we're going to do no problem. The one after, I think we might hold off. I might reintroduce that problem later. All right, so here's how all this proportion and common denominator, here's how it's all going to work. And also, like, figures within, like sides, angles, we're going to show how they're all proportional to each other as well. Zoom out a little. I don't know why. This seems like my computer screen is much smaller than usual. All right, so, okay. So how about this? 3, we're going to talk about, don't worry right now about number 4. If you want to cross number 4 out for right now, you can. Don't worry about this one. We're going to deal with that one later. Let's focus on 3. Okay. So for number 3, who can tell us what's given?
Height is 8,
So the height is 8.
width is 6, and length is 10.
All right.
That would be 8 colon 6 colon.
You're on the right track. Here's where you have to be careful. All about the order. So this might be an idea where if you have highlighters or you want to underline. Now, I like how you designated height.
Width, height.
That's all good here. You go 10 for the length, 6 for the width, 8 for the height. That's okay. But now, look at our wording. Look at the wording. That's going to help us determine the order we put each numbers.
So it's 10 to 6.
10 to 6 to 8. It's right here, the length to width to height. That's the most important part of the whole problem. This part. The length. Now you put colon up to you, width. You could also just abbreviate it if you wanted to do LW.
Divide by 3.
So in the end, the length, which is 10 centimeters, 6 centimeters, 8 centimeters can all be divided by what number again, Jez?
4.
Can all be divided by 2.
Length would be 5, width would be 3, and height would be 2.
So then the length, 5, W, 3, and height, 4. That would be your simplest ratio right here. Because if you multiply all these numbers by 2, you get that result. But again, the key is figuring out that common number, common value. We divide all the numbers by. Okay, so far, any questions? That's gonna be the code, the goal. Try to figure out what works for all three numbers. Because 10, 6, and 8 all work with 2. All right. Questions on this first problem? The next three we're going to talk about, they're going to be a little more in detail. But we're going to have to remember some previous rules in life. All right. All right, so here's what's going to happen. This we might know, but let's talk about this. So given this triangle JKL or JLK, they said angle J is X. Angle L, 2X. And then angle K, 3X. So that's what we have so far. Any questions up to this point? If you want, label your triangle. X, 2X, 3X in the appropriate spots. Where's your agenda? And whatever you get, you gotta, whatever you miss, you have to get from a neighbor. All right, now, we want to try to figure out what the measures of these angles are. Wait a minute. Okay, look. Oh, no, there's actually one. All right, hold on.
Why is there an X behind it?
Oh, which one?
Like, why do you need the X?
Okay, the reason why we need the X is because what's going to happen is you're going to have the same number for all three.
So you have to multiply them?
Well, once you get your X,
Yeah.
then you multiply the X out of about 2
Yeah.
to get this angle, or 3 to get that angle. That's why we need the X. Because we don't know what this one is, however, they're saying that angle L is twice
Like you get in?
in a moment. Well, here's what we do know.
Or you do like
In the end, you will.
If we get the N.
When you get your X. Give it back. So, hold on, let me write. Let's see, so, okay, you know that's 1. Some more. That's it. All right. So going back to this problem. We're going to get the X. Once we get the X, then we're going to be able to figure out the other values. Now, we're going to find all three measures, like angle K, J, and L. But what is one thing we definitely know about the sum of those three angles? What must the sum of all three angles have to add up to be?
180.
Very good. Here, you have to know X is 2X, is 3X, is 180. 180 degrees. Do we agree to that?
Yeah.
X plus 2X plus 3X is 180 degrees. Now, notice how all three terms have an X. Yeah, so how many total? So how many do we have in total?
6X equals 180.
1 plus 2 plus 3. UCLT, bang. 6x is 180. So 6x is 180. Bingo. X is 30, very good. X is 30 degrees. So now we have X, so we said that angle J, which was X, but X is how many degrees? How many degrees is X? 30. And then angle L, which is 2x. So what are we going to do with the 30 and the 2? Plug it in.
K is 90 and L is 60.
All right, very good. Angle K. So the measure of angle K, 90. Measure of angle L, 60. And the measure of angle J, 30. And as Des said, if we add 30, 60, 90, you get a grand total of 180 degrees. And really quick, let's say if we had, I'm just going to write this up here on the top, 30, 60, 90. What can we divide all three of these numbers by to get the lowest possible value? We can divide by 3.
2.
Biggest number. What's the,
What was the question?
all right. You said that angle J,
We divide by 6.
you divide by 6. What's the biggest possible number?
9.
9's not going to work for. Oh, no. This is angle L. 10's bigger. You're getting close.
Oh, it got bigger.
Oh, yeah, it's definitely bigger than 10.
20.
Not 20.
Is it lower than 20?
Higher than 20.
30? 30?
It is 30.
So you put it
What
like,
do I like that?
it's 1.
1.
60 divided by 30 is 3. Yeah, 30.
Well, there you go. Back to 30. And then that's how we, in the end, we get that 1, 2, 3 right ratio. And we sort of had it in the beginning. Because with the x, you multiplied all these numbers by x. That's how we got our angle measures. Now, and again, you weren't asked this part. This was just more of the extension, like working backwards. How when we set up our equation, do our division, multiplication. It could be on multiplication because sometimes we might have to multiply everything by something. Let's say if you're going from smaller to bigger, you're multiplying. If you go from bigger to smaller, then we divide. This was just more how x, 2x, 3x, how many n, once you get your values, divide by the value of x, you get these smallest possible numbers. That's what we have going on here. Okay, any questions with this problem here? And I do apologize, it's going to be, this part here is going to be one of those where practice, practice, practice. Now, the good news is you all have an extra day where we can either review, relearn, or finish this activity. Because I know next week we meet regular, but what's gonna happen is, if this was a period 2, we'd have to do this all in one shot.
Wait, don't we have like senior 2 and 3 now?
You do have Stinger 2 and 3 tomorrow. So that would be another opportunity, really quick, with Stinger 2 and 3. We can review anything we did today. Also, if anybody needs to finish their mid-year point test, they can finish it. Because I'll have them graded by next week. And then we'll talk next week about what needs to be done. Okay. Here's what we'll do.
5 or 6.
So 6 is actually similar to 5. 6 is very similar. Because they had angle A was 3x, B was 4x, C was 8x. So 6 is very similar to 5.
I have a question.
Yeah.
When is the quarter this quarter?
And it's not gonna end until the 31st of March. So about 2 months. So it's gonna be the last day before the spring week.
Spring break.
No.
Something in July, March something.
Yeah. And so end of quarter number 3 will be March 31st. Mm-hmm.
So we have to break after it?
What's that?
Is that still break after it?
Yeah. Yeah, a week off. And for you all, you actually get sort of, yeah, because you'll have that Friday off too. So. All right. So for number 6, 6 is going to be similar to 5.
So you do 3x plus 4x plus 8x plus equals 180.
That's your step. Yup.
13x equals 1.
So does everybody understand where we're getting these 2 steps? So the angle measures,
X 12.
and then you get 15 because first off, set it up. So angle A, remember angle A, angle B, and angle C have to add up to 180. That's when you get this part. This is angle A, angle B, angle C. You add them up. Combine like terms, 3, 4, 8, 15x, 180. And then Dad said something about getting to 12, right? By both sides of 15. And then boom. So x is 12. Now, when we finish stuff, what do we have to do with the x to get all them other angles?
So it would be, A would be 136.
Okay, angle A, so the measure of angle A, 3 times 12, which is 36. Measure of angle B, this is 4 times 12. I'll put those values up in the measure of angle C, 3 times 12. So the top one, 36. degrees,
48,
48, yep, and 96, yep. So there's your angle measurements. And then, of course, you can put them in here as well. But that's the connections. This is where now connections really are going to start taking place. I know first quarter we didn't see it as much. But now we're going to see it. We're going to see it more and more every day between now and the end of the year.
Will the ratio be the same?
Yeah, because then in the end, we can divide all these numbers by 12, and then you get your originals. Good point. That's a good question. That's a real, there you go.
So the 7 as well will be the same?
Okay,
But you can't?
okay, 7. All right, we'll talk about 7. It's sort of, but there's going to be a little bit of a difference. Now, this one, the only reason why this one might be a little different,
You have to find the intersection.
right?
98 inches of the perimeter.
So the perimeter is going to be 98 inch. Now, here is where and then this one's going to kind of lead us to the next activity.
But if it equals 98,
Okay, so something's going to equal 98. So we had the perimeter is 98. Now, sides ABC are extended ratio of 356. But here was where I kind of made a mistake. I did not go in depth with this problem. What I should have done is I should have said, now, here's where the order's going to map. The 356. What does the 356 represent? Of the 3 sides. What I should have said was what each side was representing. Here's how we're going to figure this out. And going forward, you'll see more, like when we do the next problem. So here, what I should have said was, if you look at your triangle from A to B, so anytime you have like sides, like ABC, and when you do your ratio, this first number represents the first 2 letters. Then,
it's gonna be
the second 2 letters, the middle number, right? A and C is going to be this one here. That's how you're going to set them up. So that was my fault. Now, let's say on a quiz or a test, I mean, we're going to practice this more. Now, anytime you have this situation, if you're not sure about what the number is, because we know 3 plus 5 plus 6, well, 3 plus 5 plus 6 give us 98.
no.
No.
So it
Go
would
ahead.
would it be near the side? It would be in between A and B. That would be 3, right?
Okay, so it's going to be, there's going to be a little bit more. Let's keep the 3 there. And then for the 5, I mean, I like what you're saying. Okay, say that again. You just said something that was really important.
3x, 5x, and 6x.
That's what's going to happen in the end. Because we know 6, 5, 3. If we add 6 plus 5 plus 3, what's that going to give us? If we just add these three numbers straight up. 3 plus 5 plus 6. 14. 3 plus 5 plus 6 is going to give us 14.
14x equals 180.
Well, be careful. Rather than,
98.
it's going to, here's what you do. You're going to make it so that in the end, you're going to have 3x plus 5x plus 6x is 98. That's what we want in the end. That's our goal because this was our original. Well, now we want to find that number x. 6x, 5x, 3x. That's what I want. That's what I want us to find in the end. That was the connection. Because I know when we added these three numbers up, okay, we only get 14, but now, do you all want to know the real cheapo way to find this value? The cheapest way to get the x value? All right, I'll show you. Here's what you can do. Well, we said 3 plus 5 plus 6 is 14, right?
Mm-hmm.
Well, then, if we had 3x and 5x and
And then, so 14, add an x to it equals 98.
yup. And then what do we do with the 98 and our 14?
Add it into, like, 3x plus x and 6.
Yep, so we add them up, we get a 14x. That's right, the combined like terms. So we're at 14x equals 98. So now what can we do? So 14 times something is going to give us 98. So, divide both sides by 14. And then 98 divided by 14 was what number?
Oh, 7.
7. So basically, you could have divided these two. You get your x, and then you plug it in. Boom, boom, boom. Plug them in. And then you'll get your numbers. 2, 35, 21. Now, on your test, it's going to be, this question is going to be worded differently. It's going to, one of the two previous problems, problem 5 or 6, you'll definitely see. Well, something like 7, not so much. All right, here's what I want to do. So this one was probably the hardest one out of the bunch. The rest of this activity, I just want us to start talking about the top of the next page, because that's ratio and proportion. That's where the connections are really going to take place. All right. So real quick, we'll start on the next page. This is it. Now we're gonna see how human ratios, here's how they tie in with proportions, because in the end, turns out that these triangles were proportional. Because we either multiplied or divided by the same number to go smaller, bigger. All right, let's talk about proportions for a little bit and then basically that's what was happening here. It just, the proportion is where your scale, your ratios are going to be the same. Now, I showed you some examples. Now, sometimes you might see the cones of your ratios. You can rewrite them as fractions. Now, the one thing I'm going to say, order will still matter. Your order will still matter, but here's the key. With proportion, if you want to check if whether or not you have a true proportion, do a crisscross multiplication. So for instance, we multiply 3 times 2 and 6 times 1. Both cases, we multiply crisscross 6 times 1. What's 6 times 1?
Oh, yeah.
6 times 1? What's 6 times 1?
6.
6. What's 3 times 2? All right, did the cross diagonal multiplication, the crisscross products work? Okay. That's how you check. This is a check. Same thing here. Let's say if you had it in the colon form, you could write it as fractions. Then you have to check. I'll just do this bottom one for the example. 5 times 30. If we multiply 5 times 30, what do we get? Who can tell us what 5 times 30 is? Or 30 times 5? If we do 30 times 5, what do we get? 30 times 5.
150.
30 times 5 is 150. What about 6 times 25?
150.
It's also 150. Very good. So that's a way to check if everything works. So that's your way to check. And always check after you do your setup, crisscross it, check. If your products are the same, you're good to go. Now the reason why I wanted to tell you all about this way, because on a homework, which I think I'm going to postpone giving today, because only about half of us are here. I mean, if you want to look at it, you can. Up to you. You're not going to get that far. But what it is, there were some problems where the proportion was written in this form. Best way to rewrite it, if it's going to help you, is fraction form. Because what we're going to do, I think I might postpone until Monday. But we can start talking about it. Now, number 9. The only thing I'm going to tell you about number 9. Now, if you did it, that's cool. Watch your order. Especially, see this where it says A over B is 2 over 3? Everybody see that first example? But in this example, they flipped it. So if you flip A and B, do you keep your numbers or do you have to flip them as well?
Flip them.
You have to flip. So you have to flip it. That's the key. So watch your order. I'm going to tell you all that right now. Watch that order. Watch your order. Now, the last thing I think we're just going to start with these. I'm not going to talk anymore about B, C. Basically, you're just filling in blanks. But don't worry about these guys as much. So, don't worry so much about here. Worry more about your order. Now, the only thing I wanted to start to mention before we walk out is when you solve proportions, when you're solving for that missing variable. Now, you've probably done this before in algebra. I think you did this in Algebra 1 back in the day. I know, because I also teach Algebra 1. It might be a little while. Again, but with these sets of problems, it's similar to before. You do your crossing, cross multiply. Cross multiply. Do that 5 times x equals 4 times 10. Example B is the one I really want you to see. I'm not going to go much more to example A because here it just becomes 5x is 40, and then x is 8.
Oh. I got the answer, but
I mean, there's other ways you can get this. Because somebody can say, oh, 5 times 2 is 10. So 4 times 2 has to be 8. I'll accept that way too. Because, again, there's more than one road you can get to a correct answer. And you knew, oh, I can multiply the bottom by 2, that means I can multiply the top by 2. I'm down with that. Do that all day, every day. Okay, with part B, the best way to do this, anytime you see a blank, and I'm going to star this one because this one you're going to see on your homework. But I think I'm going to postpone the homework one class. I'm not, unless if you want it today. That's what I thought. I'll let y'all, I'll give you all a break. So you won't get it till Monday. How about that? But the only thing I want you to see, anytime you see a problem like this, whenever we have a blank, what can we always fill a blank with? You do that. And then what's the fraction way to write 4 colon 7?
4 over 7.
4 over 7. Keep your equal sign. It's over 35. And then we're just back to 5A. Let me do your crisscross. Crisscross. And then again, do your crisscross. No, I won't say crisscross, jump, jump. I know that's old school. I'm telling you my age right there. There you go. Although I think there's another song too. I think it was everybody clap your feet. Step to the left, step to the right, crisscross.
Wasn't that the cha-cha song?
Maybe.
I think it was.
That sounds like, yeah. Cha 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 cha.
We still know that one.
Okay, all right.
Funny.
Yup, so in the end. Yep, so 4 times 35, you get 140, and then divide by 7. Next will be 20. Good.
You're upset now?
All right. Okay, these two we're going to talk about later. These two is going to be later because when we start dealing with these guys, the one thing I'm going to tell you all, call parentheses. Now, because some of the problems that we're going to do, going to need parentheses. So, Monday, bring this back. Bring this packet back. And then and then also, well, yeah, I'll see you all tomorrow too.